For those of you that might not know the Transport Research Laboratory, we're a private organisation. We used to be a government department, but were privatised just over 20 years ago now. But we still continue to provide a range of independent research and consultancy services in all aspects of transport systems. So I work in the infrastructure division, and so I've sort of considered a bit of an infrastructure perspective today on what a driverless future might look like. Assuming that is, of course, that's not going to be consisting of fluffy toys driving our vehicles, which I think is probably rather unlikely. And I think it's also probably true to say that the future isn't going to look entirely like this, but 1969 I think must have been quite an auspicious year, because as well as me being born, man also landed on the moon, and TRL at the time was testing out a driverless car. And I think the systems today aren't going to be entirely like this, but you can see that already there was a fair degree of confidence in that this vehicle is travelling reasonably quickly. This particular technology relied on an embedded wire in the road surface, and although it did progress to some trials on the M4, it clearly wasn't taken any further. So systems aren't going to be existing in exactly the same mould. But we can see there's been research and development into driverless vehicles throughout my lifetime, and that is the pace of that is really accelerating now. And we can see two features really, both within production vehicles that are already being sold to the public. There's an increasing prevalence of driver assistance, aids which are automatic in their function, and those are already delivering safety benefits. But we're also seeing that truly fully autonomous systems are already successfully navigating roadways in vicinity and proximity of actual human drivers, and the safety of those systems is actually quite difficult to assess, but it's clear that multiple millions of miles are being driven, that there's a very limited number of incidents associated with the presence of those vehicles, and that the majority of those incidents are actually still associated with human error on the parts of the vehicles that they interact with, as opposed to failures in the autonomous systems themselves. So essentially these systems are very, very near to deployment. And we can see in the news just in the last couple of weeks, there's also Nissan Leaf is starting deployment within London on a testing basis. So these systems are already here. And we can see also that there's a couple of well-proven technologies. The Docklands Light Railway has been operating since 1987. The shuttle pods at Terminal 5, which were the basis of the technology that's now being trialled in Greenwich, have been operating successfully since 2011. Now, what's interesting about these two systems, of course, is that they've got an entirely dedicated infrastructure. They don't need to be able to interact with human drivers, and so the challenge really for the existing roadway system is how we can enable the transition between a human-driven system and an autonomously driven system. And this example really is sort of an interesting contrast, because it's not all about automation. It's more about how, by driving consistently, we can increase capacity. So I'm sure you're aware of the introduction of smart motorway systems. We've had them operating from Birmingham and on the M25 very successfully. They drive an improvement in safety and an improvement in capacity. And with greater degrees of automation, there's potential for another step change in capacity. But I think the other interesting angle is that the future could deliver us that increase in capacity, but potentially without the infrastructure that we're currently using, because all of that information could be delivered to vehicles through wireless communication rather than these rather expensive to install overhead gantries. So that produces some very interesting concepts about how we control our road space. Rather than fixed lanes, maybe there's a potential to allocate different widths of the road space to different users. We could go from 3 lanes at one speed in off-peak conditions to 5 lanes at a lower speed in peak time conditions. It would enable you to potentially address other strategic issues by allocating part of the road capacity to certain users, whether that's cyclists, ultra-low emission vehicles to improve on our air quality challenges, or freight, or there's multiple opportunities about how we could allocate our road space better to meet our strategic objectives. And it's clear from Lola's presentation that they're thinking along similar lines, I think, in Greenwich already. There's plenty of challenges, of course, for autonomous systems, and I think one of the challenges of the built environment is how we make it self-explaining. These autonomous systems operate on a fairly intelligent series of sensors, but they've still got to be able to determine how to navigate in this world, and this world keeps changing around them. So I think from the point of view of the built environment, we've got to think about how to make that self-explaining, and how the inevitable changes are also going to be self-explaining. But the interesting angle there is that in a fully autonomous world, which will be some way off in the future, but I suspect in some areas we will eventually get to that stage. In a fully autonomous system, that signing doesn't have to be necessarily designed to be optimum for human perception. It could be designed to be around the sensors that are present on vehicles, and I think that gives us an interesting possibility to declutter some of our current environment. We spend an awful lot of space and clutter in explaining to drivers how we expect them to be using the road network, in tracking the current traffic situation, and in enforcement activities as well. So a lot of that clutter could be reduced. The one area I think that we won't be able to reduce is the communications, because I think we're going to need more and more bandwidth for our communications in order to enable all of these connected services. Lola's already spoken a bit about the Gateway project, but I think this produces some very interesting thinking that's needed in terms of the rules of engagement. At the moment in our urban environment, the assumption is that pedestrians will give way to vehicles, and the development of safe systems that operate in areas where pedestrians and other human drivers are present means that there's going to be an interesting development of the rules of engagement around who gives way to who. And we know that humans are fond of risk-taking, and if pedestrians learn that it's safe to step out in front of autonomous vehicles, then we're going to have a different type of congestion problem on our hands. So I think that's an area where we're going to need where there are plenty of unanswered questions at the moment, let's say. Another question that we're starting to look at is that of validation. Now, one of the interesting consequences of accidents being rare and these autonomous systems already being relatively reliable is that it becomes more and more challenging to validate whether they're safe for operation in all possible situations. And so the MOVE project at the moment, which is underway, is doing live trials of autonomous driving systems. They're not driving autonomously, but the systems are collecting sensor data, and that is being analysed in terms of the decision-making process to see both whether they are making appropriate decisions in response to different stimuli in the environment, but also how we can develop that whole framework of assessing these systems and whether they're fit to be used. A consequence of that is that the amount of data that is being generated and collected by these systems is just exploding, and that leads really to another challenge, which is about how we successfully navigate the digital environment. From the perspective of how we manage our road infrastructure, I think there's already, with the limited volumes of data that we currently collect, we're not particularly effective at analysing it and making the most of it, and that is going to get more and more challenging as the data volumes from all of these autonomous vehicles and the services that they're provided with increase. So just to wrap up then, I'd like to sort of really reflect on some of those areas and consider what it is that we need to build in order to benefit from a driverless future. And I've really identified 4 different things. There's obviously the physical infrastructure, and we've still got the same challenges that we want it to be durable, resilient, safe, sustainable, non-polluting, etc., etc. None of those have changed, but I want to introduce an additional criterion, which is that it needs to be flexible. And it needs to be flexible both for multiple users and to be reconfigured. And that applies on different timescales. It needs to be reconfigurable to suit peaks and troughs in demand, but it also needs to be reconfigurable as vehicles change in the future. We're just seeing that the pace of development is so huge that it's impossible to really predict what the nature of vehicles in 20 years' time is going to be. So what that must mean is that we need to design our physical infrastructure in a way that we can readily adapt and reconfigure it. And I think for me, one thing that's interesting here is there's been a lot of debate about the HS2 corridor, but I think actually some of that debate is addressing the wrong question. I think, yes, we do need a new electrified corridor, but the question for me really is what is the best use of that electrified corridor? Is it really to be running occasional high-speed passenger rail services, or could we imagine actually a electrified transport system that could possibly deliver different and more flexible benefits to our future? Second, I think, is data, and Lola again alluded to this. Data volumes are increasing rapidly. We need the hardware, software, and above all the skills to be able to make the most of that and benefit for it. Communications is going to be another one. What's a vision I could see is with this a big multiple linked data set being shared in real time between vehicle users, transport users generally, network operations, enabling our operations and planning to be much more to be planned on a much more holistic basis, where we can take in all of the positive and negative effects and make decisions on an informed basis, which we're trying to do already. But I think the volumes of data and the communications, if we can get that right, that allows us much more opportunities to serve the needs of the public. And then finally, I think it's time really to start developing the social questions as well. I could envisage that the continued demand for travel services would reach a point to which our transport systems just become clogged to capacity, and the consequence of that, if unchecked, is that actually the performance of the system becomes degraded and nobody goes anywhere very quickly. Now, we could allow that to happen, or we could begin a different discussion about how we allocate transport capacity to a range of different users and how we do that on a socially equitable basis, because the traditional method for rationing capacity is just to do that on price, and it might be that we could find a better way of doing that that allows economically and socially advantageous mix. But I think we need to have a degree of realism here about whether we're able to build all of the physical infrastructure that people would like to have, and if that's not the case, then how exactly we're going to manage that. So, thank you. I apologise if that was a slightly random, rambling description, but I think there's some interesting challenges for us to be addressing. Thank you.